So, shall we begin? Excellent. This talk is about a device which I'm going to explain about later. So if you want to see it in reality, just look at it. Come to see me later on. But first, I'm Harry Sintonen from F-Secure. And now people are thinking that, okay, antivirus and stuff. No, we are doing more than just antivirus these days. F-Secure is doing lots of cyber stuff these days as well. So I'm one of those cyber guys. A bit about this device. It's a Wi-Fi smart socket or power plug which you can control with your phone or iPad or whatever. And what they are saying about it is that the app sends signal to the cloud server. Cloud server translates the directive and forward to the Wi-Fi plug. So it says that it uses cloud, but I don't know, does it? You can get this from Lidl. I got mine for 30 euros. It's not that expensive. And this is what it looks like. So the plug is now connected, and I have my phone, which I can then, hopefully, use to control the lights. So I can turn them on, turn them off. Oh! Amazing, it works. So what I'm using now is the official application, which is using cloud, connecting to somewhere, doing something. I don't know what is going on. But basically, this is how it normally works. So what is this thing anyway? It's called Silvercrest SVS A1. There's a specific model number here, if someone wants to look it up. And what it does, it just controls the plug. You can time it. You can say, I want the lights go out during the daytime and then go lights back up in the evening or something like that. And the web application or mobile application is using some cloud server to control it. And you log on with your username and password to the application. And the application then connects to somewhere, and then you can control your devices. You can have several plugs. You can have something like 10 or 15 if you want. And you can control them from your application. But the description is extremely misleading. It says that the control is coming from the cloud. But is it really happening like that? No. This is the reality. So what we have is the mobile application. It's connecting to the internet, through internet to the cloud server. And then at the same time, the plugs are connected to LAN, local network. And the mobile application only works if you are connected to the same local network as well. So is it really doing so that when you do something with your mobile application, it's going to connect to the cloud server, and the cloud server is sending you a command through internet to your mobile app and then to the actual plugs in your LAN? I don't think so. But this is what it says. And this is what you do normally. You just connect to with the mobile application, and you control your devices. You can add them, remove them, program them, and things like that. So this was interesting, but I don't know. Maybe we should look into things. So what I was thinking about, how would I start looking into this thing? Maybe first see what it looks like in the network. If I connect one to my own home network, how does it appear there? Are there any things open? Then maybe if I connect it and see what the traffic looks like between the application and the device, and maybe the device is calling directly to the internet. I don't know. Maybe something like that happens. So I'll want to Wireshark or TCP dump everything. And maybe then if I can open the device, look at the device, see what is going on, then there is some chips I can recognize or some part numbers I can Google. Maybe something that helps me. And also if I can find the firmware updates, those are useful because you can usually reverse them and find juicy bugs in them, which you can exploit. So first recon, try to find as much as you can. Then analyze. So if I can see something, can I possibly find some vulnerabilities? Can I find default credentials, say, maybe? And see what protocols are being used. Is it something familiar? Is it something completely different? Something I haven't seen ever before? Maybe do some hardware analysis, but in this case I didn't have the time. If I would have done that. What I did, I took the mobile applications. So I downloaded for the application from iOS and Android and reversed those. These are handy things to do. And then if I get the firmware somehow, I could extract it from the device or find updates from internet, decompile, reverse that, look for backdoors, exploitable vulnerabilities or something like that. Then finally, exploit it. If I find something, create exploits, profit. Yay! So first, scanning the device. Well, the usual tools, nmap, see what's open there, and maybe try to access them if they look like some standard things. And the first thing I saw, like 5 minutes, is this. And the credentials are admin, admin. And what you can see here is upgrade software, browse, select the file, and upload. So basically we can pwn these things, just upload a new firmware, and that's it. But I don't know, it could be a bit difficult to program some device that you know nothing about. So I didn't use this in reality. Maybe this is something for a future study. Yeah. So I also saw something interesting. If you somehow get to connect to the device, you can see the wireless Wi-Fi key from the configuration. So if you somehow, well, usually when you connect to it, you connect with the same Wi-Fi network, so you know the password anyway. But this device also reveals it. This is the similar thing that you saw a couple of days ago with the doorbell thing, that you could extract the Wi-Fi key from the doorbell. But it was different because the doorbell is outside and you can physically connect to it. This might be inside or something, usually. But if you get access to the device, you can extract the Wi-Fi key from it. Also, there were a couple of custom protocols that I didn't identify. UDP and high ports, something that wasn't obvious what it was. So I still use TCP dump to see what's going on there. And this is what I saw. For instance, it's using clear text connectivity to the cloud. So it's MD5 of the password you are using. So thank you. You are just giving out your MD5 hash of your password. And as we know, MD5 can be brute forced easily. So unless if you have an extremely strong password, you are basically just broadcasting your password to the internet. That's a good thing to know if you're using these devices. So have a good password or something you can throw away. Then to UDP traffic. This was interesting. It was encrypted. Ooh, that's nice. So I couldn't really make out this thing. It's gibberish, and that's a downer. I can't tell what's going on. Also, when I sent the same command several times, the content changed every time. So either they were using something like cryptography properly, or they were doing something else. But still, it was a bit of a surprise that they were doing something like that. That's encryption, that's interesting. So the results were from network sniffing. So it's using clear text HTTP connections, and it's using MD5 of the password, which was like easy to see. And well, if you get to sniff the network traffic, you can extract the MD5 hashes and crack them. And the UDP thing uses encryption, so I had to look into that in more detail. But before I did that, I continued with the recon. I looked for online documentation because this can be rewarding. I mean, what I did, I didn't actually even open the device. I looked up the MAC address. So usually you can look up the MAC first 24 bits, you can take them and use search and see which device manufacturer it is. And it was high-flying electronics technology company. And just Googling a bit, I found some chips that matched the features. High-fly LPB100. And luckily, they had all this development material and things online, which were extremely useful, because you can confirm that, okay, there's this administration interface, which has admin default credentials. And also, it explains how the device auto-configuration works. When you initially introduce it to a network, you push a button, and then it automatically knows how to connect, which is kind of like neat. There's something that could be attacked as well, I guess, but I didn't look into that. But it explains how the chip works inside. But still, I would like to have controlled the actual power switch. So this wasn't included in this documentation because it was about the chip inside the device, not about how this particular implementation was working. So at this point, I was like stumped a bit because, well, what next? I have this encrypted UDP traffic that I can't figure out. So decompiling the application might help. So iOS, I dumped the application with dump decrypted dilib and decompiled the binary with Hopper. From Android, I used Dexterjar and decompiled the code with Prosuan Java decompiler, which is excellent. It's really good. And as it often is, unless if you are like real ARM pro reading assembly, it might be easier to look at the Java decompile. It's much easier to read. It's almost like C, or well, it's Java. Well, yes. And this is how it looks like. So it's a bit hard to read what's going on here, but still, if you look at it a bit, you can see that it is creating some frames. It's creating a byte stream. And first, it's creating inner and outer layers of commands that it's sending. And the encryption is here later. So basically, it's creating a payload, it's encrypting it, and then it's sending the UDP to the certain port. And the device is doing the reverse, decrypting it, and interpreting the command and doing something. So I figured out that, okay, it's AES, CPC mode. It's properly padded, which is nice. And encryption key was generated dynamically, and it was modified on the fly. So that explained, while it wasn't using initialization vector properly, it was still using random or modifying the key on the fly. So that explained how it wasn't obviously the same payloads weren't encrypted in the same ciphertext. So what I could see from here is the specific frame formats. So here is the actual frame format for the command itself. So there's a 1 byte 1, then there's an encrypt flag, which tells me if it's encrypted or not, which I come back to a bit later. And then the destination MAC address, which device is it being sent, the payload length, and the payload itself. Then the actual command is the payload, and it begins with a 0, then some IP ED number or PAC num. It's just a running number. It doesn't really matter. You can use anything there. Then there's a company code, device type, auth code, then command ID, and the command itself, parameters for the command. So these things inside the package that's encrypted. But there's this flag, encrypt flag. So that's handy. So probably the device is actually accepting unencrypted commands, which is handy. I mean, because now I don't need to care about the encryption anymore. I don't need to even figure out how it works. So I can just create unencrypted payloads and send them. Oh, it works. Brilliant. Then the authentication code. Everything here, the company code, the device type, that's specific to the specific model. So as long as you're using certain devices, those are constants. So in this case, C1 and 11. Then the auth code is 16 bits. So basically, that appears to be the whole thing, the whole protection against unauthenticated commands. And 16 bits, it's not enough. So can we find something interesting? Let's see. So here is control GPIO status method. And it has two different modes, close and open. Close and open. So, this sounds interesting. I wonder what it does, and I wonder what those constants are. So, 0, 0, -1, -1, 0, 0, 0, -1. One opens the circuit, and one closes the circuit. So, now it looks like that, well, it does support clear text payloads. We can send this encrypted stuff to it. And the protection, well, there is some, but 64K possibilities. So just try every one of them and it works. So we can completely bypass all this cloud thing that is there. We only need to crack the auth code, and we can talk to the device directly. We don't need to even log into this cloud. We can completely forget about it. Nice. So now the fun part is that the device has some status command which responds as soon as you have the correct auth code. And so what I can do is I can send all the auth codes to my local network just in order, and as soon as something responds, it says that, okay, this is my IP address and this is my auth code because you just sent the correct one. So I can brute force all possibilities, and as long as there is at least one device there, I get a reply. If there are 3 devices, I get 3 responses when they see the correct auth code. As soon as I have the IP address and the auth code, then I can use those values to send specific commands to specific device and control them as I see fit. So here comes live demo. I'll drop this for a moment. So here I'm trying, I don't even have to know the specific IP address, I'm just sending broadcast stuff. And I'm trying to crack the device. Before we start with that, let's see if everything is in working order, because the thing is a bit fragile. If I do stuff with it, it can die on me. So let's see if it works. Let's take some moment. Because it would be a stupid demo if it wouldn't work at all because the device is dead. So let's see if we can still toggle. Yes, it works. Excellent. Let's try this. So now it is trying to crack the authentication. I hope it's visible for some people at least. It's trying all possibilities for the authentication code. And hopefully things are working as they should. They are not. Brilliant. Demo gods. They are not with me.
Demo effect.
Yes. So it's a correct network. Ooh, what's going on here? It works, right?
So you know the code is written at the very low end of it?
No, it is. It's actually a bit high. So I know what the code is, obviously, and it ran past it. This would suck if this wouldn't work, because I developed this exploit for quite a bit. Yes, woohoo! So now it found something, and now it goes back, trying to narrow it down. Which is it? Which code? And there we go. 7150 for the device, and I'll just scroll it up so people see. So what it did, it found some auth code near 7302, then it went backwards because it doesn't tell me what the code is. It just said that, okay, here's my device information. So I have to go back and try to narrow it down to specific code. So once I have the code verified, then I print out. So confirmed auth code is 7150 for this specific device. And that's the device sitting down there. So next, let's see. Now we have this information that we can use to connect it to it directly. Let's see what we can do. So this is the real way to control it. I'm not using it. I'm using my computer. And as soon as I use it correctly, it'll work. So I'm just toggling it on and off, which is nice. But consider if you have some device that would actually maybe break down from fast switching. This lamp is a bit slow because if I try like 50 times per second, I doubt it's going to keep up. Hopefully it stays alive.
You want to break it up?
Now, if the audio is working, yes. So what I'm doing now, I'm polling the device and asking it, are you currently powered on or off? So now the unsuspecting user is coming and trying to turn it on. See what happens.
Nope, I'd rather have darkness.
Oops.
Nope, I'd rather have darkness.
What's going on here? Come on. And similarly, I can, let's see, let's toggle it first so it's on, yes. And so let's do the reverse. So I want to turn the lights off.
Nope, I'd rather have light.
Yeah, which was nice. So, obviously, if you have some built-in administrative interface in your device, it should be disabled completely, I would say, or at least have some non-default credentials for it. So maybe it would be like serial number or something that you can't predict. Also, well, the design of the chip itself is setting these limits, basically. So you can't build a secure device on top of this. So doing whatever you're doing, like adding encryption on top of it, it won't help really. It makes it a bit more obfuscated and makes it a bit more difficult to reverse, but it merely slows down you a bit. It's not going to stop anyone. And security through obscurity is not working. You just need some time and dedication, and you can do pretty much everything you want. And cloud, well, it's a magic word. You just use cloud, and everyone wants to buy your product. In this case, it's not even using the cloud for anything useful other than managing the devices. That's it. That's the thing. It has nothing to do with the communication with the device. And in this case, because they are using plain text HTTP and they are using MD5 passwords, they are actually making it just worse because they are revealing your password hashes to anyone listening. So come on, don't do that. Then maybe some future work. Maybe when I have some spare time, which I don't, maybe reverse engineer the actual encryption as well, so just for fun of it. Dump the firmware because I couldn't find anything to download, so maybe dump it from the actual hardware and see what's in there, which platform it is it something custom or is it something which I know about or something, maybe. And more hardware analysis, maybe open it for the first time, because in this case I didn't even have to open it to see what's going on. And proper write-up, that would be nice. Then, because this device usually is being connected to your local network, you would think that, well, this isn't really a problem, is it? Because, I mean, you can't connect to the device from the internet. Well, I guess, maybe, I don't know. But since this is a device that does, just when you connect it to the network, it gets an IP address and just sits there, everything is open. As soon as you have a configuration which gives you a public IP address, you could be in trouble. Oh, what is this? The power plugs are on the internet as well. This is interesting. So basically this means is that you can actually control some power plugs all over the world. I wouldn't do this, obviously, and neither should you. Because it's obviously extremely illegal, but still it's there. There aren't that many. Some interesting points are that many of the devices, most of them are in United Kingdom and Germany. And if you consider the fact that the device is being sold by Lidl, that's so obvious. What are the most important countries? Germany, maybe United Kingdom. So I wouldn't recommend doing anything stupid on the internet. As long as you play with your own device, it's fine. And that's it, basically. Thank you.